Hi friends, I'm Aaron. You are watching Aaron Lab. In this video, I want to explain the working principle of AC series motor. And I'm explaining the how can we change the direction of rotation of armature in the motor. And if it is any mistakes in this video, then please comment. Then it will be rectified. Okay guys, this is what I have get from the theoretical circuit diagram of AC series motor or universal motor, and I am using the AC supply. If you want to use DC supply, because I am using at starting first half cycle instant, that was positive off cycle, so plus here, negative here, so current flow diagram is like this. So if you want to use this supply also, because this supply is the plus and minus value, so plus here, minus here, and flow of current is like this and through the windings. And you have to remember some points here, that was A, B, A dash, B dash. These are the points. A dash and B are the point at the brushes, and A, B dash are the input supplies. So by using the right hand thumb rule, this the current flow like this. So these four fingers indicates the current flow, so the thumb finger indicates the flux. So flux is this direction, right to left. So here north pole and here south pole. Then coincidentally it was also north pole, south pole. Fleming's left hand rule, identify the direction of rotation of rotor, and this finger indicates the current flow inwards. So first we have to draw some arrow mark inwards the finger, which will indicate the current direction inwards. And this is the force of magnetic field. This also indicates this one, up and upwards of thumb finger. So the flux is north to south, so I'm rotating the paper. The flux is north to south, so force of flux is like this. And in this armature conductors, the current flow is inverse, that's why I'm indicating the cross. So inverse flux, so inverse current, and left to right flux. So direction of rotor is this direction, means you say like this position, same position it was anti-clockwise direction. Okay, and it is the next instant of AC supply, that was negative off cycle, and indicates the changing the terminals of this supply. So plus and it was minus. Current direction is like this. So same indicates, and these conductors has the direction of outward flux, outwards current, that indicates the dot, and these conductors have the inwards current, that indicates the cross. So when I apply the left hand rule, this for use for motors. So here we're using the motor, not a generator, that's why I'm using left hand rule. So this will indicate the flux, the current direction is inwards, the direction of upwards. So like this also be anti-clockwise direction. So whenever we given the AC supply also, it will definitely rotate on same direction only, not changing any direction, rotation of direction. So that's why we got a problem in our previous video, that was we changing the terminals of DC supply, but DC supply, but the rotation of rotor is same, always clockwise. So we have to change the rotation of the universal motor. So I draw another diagram for this. This was the changing the internal connections of the field windings. That was when you see it is the, okay, remember one thing, it is the A, B, A dash, B dash. This is the winding, and here also A, B, A dash, B dash. When we see this, actually A is here and B is here, but I'm interchanging the field winding terminals. So A is here and input is B, not A. And here also A dash is here, B dash is here in previous diagram, but here B dash, A dash. So the field terminals will be interchanged given the DC supply or AC supply. If you consider AC supply, then it is a positive off cycle. And okay, now also apply that it's a cross. It's a cross because current direction is inwards, and here also outward direction, that was dot. You have to Remember this carefully, because if you interchange this also, then the direction of we will get the not accurate direction, it will be false. Okay, so flux is this one, inverse direction, so it may be clockwise. So okay, and next case is negative half cycle, plus minus, so that okay representing here. So now see, the flux is, I'm rotating the paper, not to S, and the inverse current is this, so direction of rotor is this one. Say same direction means clockwise direction. And we give the S supply here, the direction of must be in clockwise, or if we changing the D supply terminals also, it must be rotated in clockwise, but in this case it may be anti-clockwise. Okay, so this is about, and we do it practically by using a cutting machine and changing the terminals of the field winding terminals of the AC motor. Okay, let's do it.